We often rely on averages to understand data, but a single number can be deceiving. Imagine two groups of students with the same average test score. Does that mean their performance was identical? Not necessarily. This is where we need to look beyond the average and explore data variability. Variability tells us how spread out our data points are. Without understanding variability, the average alone gives us an incomplete, and sometimes misleading, picture. It's the difference between knowing the average temperature of a city and knowing if that temperature swings wildly from day to night. Our first measure of variability is the range. It's the simplest to calculate. Just subtract the lowest value from the highest value in your dataset. If test scores range from 50 to 100, the range is 50. It gives us a quick, rough idea of the spread. However, the range has a significant limitation. It only considers the two extreme values. A single outlier can dramatically inflate the range, failing to represent the typical spread of the majority of the data points. It doesn't tell us anything about how the data is distributed in between those extremes. To get a more robust understanding of spread, we turn to variance. Variance measures the average of the squared differences from the mean. We calculate how far each data point deviates from the average, square that difference to eliminate negative values, and then average these squared differences. While variance offers a comprehensive measure of data spread, its units are squared, which can make direct interpretation difficult. If your data is in kilograms, the variance will be in kilograms squared, not very intuitive for practical understanding. This is where standard deviation comes in. Standard deviation is simply the square root of the variance. By taking the square root, we bring the measure of spread back into the original units of our data, making it much easier to interpret and compare. This is why it's arguably the most commonly used measure of variability. A small standard deviation indicates that data points tend to be close to the mean, meaning the data is tightly clustered. Think of it as a consistent, predictable dataset. For example, if a product's weight has a small standard deviation, it means most items weigh very close to the average. Conversely, a large standard deviation suggests that data points are spread out over a wider range of values, indicating greater variability. This implies less consistency and more dispersion within the dataset. A stock with a high standard deviation in its daily price changes is considered more volatile. Let's revisit our student example. If Group A has an average score of 75 with a standard deviation of 5, most students scored between 70 and 80. If Group B also averaged 75 but had a standard deviation of 15, their scores were much more spread out, perhaps from 60 to 90, or even wider, despite the same average. The standard deviation is particularly powerful when combined with the mean, especially for normally distributed data. For such data, roughly 68% of observations fall within one standard deviation of the mean, about 95% within two standard deviations, and 99.7% within three. This is known as the Empirical Rule. This rule provides a quick way to gauge where most of your data lies. If you know the mean and standard deviation of a population, you can estimate the proportion of data points that fall within certain ranges, without needing to look at every single data point. Understanding standard deviation is crucial in many fields. In quality control, it helps identify inconsistencies in manufacturing processes. In finance, it measures the risk or volatility of an investment. In science, it helps determine the precision of measurements and the significance of experimental results. So, the next time you encounter an average, remember to ask about the variability. Looking beyond the average and understanding measures like range, variance, and especially standard deviation, empowers you to truly interpret data, identify patterns, and make more informed decisions.